Today's show is sponsored by BMC, and BMC wants to know, is your business on its A game? The A game is when systems are intelligent by learning from markets, where automation is paramount yet effortless, and when technology and people work as one in an enterprise. The A game is your business at its absolute best. BMC calls this the autonomous digital enterprise. Find out more at bmc.com/agame. That's bmc.com/agame.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. February continues to roll along, getting towards the end of February, almost into March, so 2022 is cruising along very quickly. Let's jump right into Cloud News Week. A couple of interesting things, and then we're going to dive into a sort of an interesting new topic that we're kind of excited about, and kind of a topic we haven't touched on before. So let's get right to Cloud News of the Week. First off, a couple of acquisitions and a couple of companies that we are familiar with, or you'd be familiar with if you listen to the Cloudcast. Fugue, who is a security company we've had on in the past, was acquired by Snyk. So Snyk continues to expand upon their security footprint, their security offerings. Fugue is a company that, again, all in sort of the developer DevOps security space. So another DevSecOps play. So congratulations to the team at Fugue. Second one, former sponsor of the show, Linode or Linode, depending on how you like to pronounce it. The company who really, made a name for themselves, making it simple to get Linux VPSs and, kind of have carved out a niche for themselves around sort of Linux-centric cloud computing, was acquired by Akamai. So Akamai, obviously incredibly well-known in the CDN space, and CDN is going to be a little bit of a common theme this Cloud News of the Week. Obviously, we've talked in the past about some of the things going on with Cloudflare and the work they're doing around bringing compute out to the edge with their CDN network. And now Linode getting acquired by Akamai. There's a really good, if you really want to dive deep into what happened with this acquisition or what it potentially could be, go take a look at Ben Thompson's write-up from this week over at Stratechery. He's been covering this space quite a bit, both with Cloudflare, but also looking at what the whole sort of CDN market's doing and how it can potentially, start to erode or eat into some of the things that Amazon does. So interesting to see both those acquisitions. The Fugue one did not have a dollar amount associated with it. Linode was bought for $900 million. So nice acquisition there. Congratulations to the Linode team. And then kind of building on this sort of CDN type of theme or the idea of pushing compute closer and closer to the edge, AWS is expanding out their local zones. So this was something that was announced, I believe it was last year, might have been the year before actually, talking about bringing essentially sort of extending AWS regions out to physical locations. So not just, a region, US East, but really expanding it out into a number of specific cities. So originally they rolled out 16. They are rolling out 32 more cities around the globe. So giving them a really big point of presence, kind of extended point of presence, if you will. So 48 cities. The full list is in the link to the show notes. It's in the Cloud News of the Week. So I think this is, feels like a big deal. More and more companies are trying to figure out what their edge story is. More and more of them are doing, services that are, metro based and all sorts of things like that. So this potentially, becomes a big deal. Again, extending those AWS services closer and closer to the users and the data. And then finally, last thing, another sort of Amazon story. Amazon and Elastic have reached an agreement on their trademark infringement. So Amazon was using the Elastic name in their Elasticsearch service, and they kind of went through some legal back and forth about a year or so ago. Finally got that worked out, and the two sides will now let their lawyers go and work on something else. So if you're into sort of lawsuits and copyrights and trademarks and stuff on open source, that one's for you. But with that, we're going to kind of wrap it up. Not a huge week, a couple of acquisitions, but we're starting to get into where we're going to start to see show season start to kick in March and April and May. So I think we'll start to see more and more announcements happen. But it's been a little bit of a slow year so far for 2022. Obviously, there's a lot of other things going on in the world to keep us occupied. But we'll wrap up Cloud News of the Week, and like I said, we're going to dive into a new topic we've never really covered on the show. It's called Data Observability. Obviously, we've covered observability from a platform and an application perspective. But we're going to dive into data observability right after the break. Today's show is sponsored by Usage AI. Usage AI is for companies trying to rein in their AWS EC2 spend. Usage AI is the only cloud cost platform that automatically applies the cost savings recommendations they provide you, netting you up to 57% off your EC2 spend. No code change, no downtime, and no engineering work required. Usage AI's automated reserved instance manager automatically buys and sells 3-year, no upfront reserved instances on your behalf to maximize your coverage and minimize your compute spend. Bundled with a buyback guarantee, Usage AI allows companies to get all of the savings of reserved instances with none of the long-term commitments. They are contractually obligated to buy back your reserved instances at any time. Sign up in as few as 5 minutes to join companies like Deal, Kick, and FabFitFun by visiting usage.ai/cloudcast to get started today. That's usage.ai/cloudcast. You know the drill. You're falling asleep and you're awakened by an emergency page. It's your night on call and something's wrong. The good news is you've got New Relic, so you can quickly run down the incident checklist and find the problem. The lambdas seem good, but something's up in the APM. Dig deeper, and there's another set of errors in Kubernetes. Ask the team to roll back, and the problem's solved. That's the power of combining 16 different monitoring products into one platform, so engineering teams can see across their entire software stack in one place. You can pinpoint issues down to the line of code and resolve it quickly. That's why dev and ops teams at DoorDash, GitHub, Epic Games, and more than 14,000 other companies use New Relic to debug and improve their software. Whether you're at a cloud-native startup or a Fortune 500 company, it takes just 5 minutes to set up New Relic in your environment. The next late-night call is just waiting to happen, so get New Relic before it does. You can get access to the whole New Relic platform and 100 gig of data free forever with no credit card required. Sign up at newrelic.com/cloudcast. That's newrelic.com/cloudcast. And we're back. And, folks, if you've listened to the show long enough and you know that there's always a couple of things that always really kind of scratch an itch for us. One of them is we get a chance to talk to, founders of new exciting companies. Two, if we get to talk about some things that we've never really dug into before. And if we can combine those two things together, we always find not only it's exciting for us because we get to learn, but we also find that it's also some of the best shows that we have. So really excited today to talk about a topic that I feel like we've sort of scratched the surface on, which is observability, but we've never really dug into data observability, all right? Like we've looked at platforms and applications, but we've never really dug into data observability. And so really excited today to have Kevin Hugh, who is co-founder and CEO of Metaplane. Kevin, welcome to the show. Great to have you on.
It's such a pleasure to be on the show. Like I mentioned before, it's really great to talk with someone who's been in the podcast space for so long. The Cloudcast was one of the first podcasts I listened to over a decade ago when first getting into engineering. So I appreciate all the hard work that you put into making this happen.
Yeah, well, we appreciate you being a listener and especially for sticking with us for so long. There's a lot of other options out there. Before we dive into Metaplane and data observability, give us a little bit of your background. You've done some pretty interesting things at very, very high level. So give us a little bit of your background and then what ultimately led you to starting Metaplane and getting into this space.
I originally wanted to become a physicist. That's what I studied in undergrad. And throughout the course of studying physics, one of the big hallmark courses is experimental physics. At MIT, they called it the junior lab or J lab.
Okay.
And this was a very challenging course by reputation. Every 2 weeks, you replicate a Nobel Prize winning experiment. And I remember, it was super interesting, whether it's like counting muons or making all sorts of different measurements. The first week you do the experiment, and the second week you analyze it. And I remember thinking like, wow, all of my colleagues are so talented, but everyone did the first week, the actual experiment in the same amount of time. It was the second week when you have to analyze the data and then communicate your findings that turned into a huge bottleneck for some people. And that really inspired me to go into computer science, right? Trying to build better methods for people to analyze and visualize data, because it's so ridiculous that you have so many talented people in the world who face this enormous friction because they essentially don't know how to write R or MATLAB.
Yeah. No, that's sort of fascinating. You went into an area, obviously, physics has a lot of breadth to it, but you sort of got into that, and this one sort of project, if you will, or even one subpart of a project, shifted your thinking, shifted where you wanted to focus. That had to be sort of an interesting moment for you, I would assume.
Well, I think I really went back to the drawing board and realized I am not a 10x scientist. Some of my classmates at the time existed on another dimension. You know how sometimes you meet these people that solve problems in completely orthogonal ways, very original thinkers. That was not me. But I thought, if I could help build tools that make 10 other people twice as effective, isn't that the same thing as being 10x?
Yeah. No, I I can completely agree with you. I remember the moment. Yeah, I remember the moment in college. It was probably about a week or so in that you realize like the people around you they're just at a different level, and there's a moment where you're a little bummed out at first because you're like, oh man, what am I getting myself into? and then you're kind of in awe of it because you're like, there's just, it opens you up to a kind of a realization that the world has just different levels of pretty amazing people. So yeah, and I know it's been a long time, but I used to do some work where we sponsored some things over at MIT, and yeah, the level of people that are there sometimes blows your mind. So let's dive a little bit into the space that you're now living in, which I'll call it sort of data engineering, if you will. There's probably a lot of things, but give us, let's sort of start about kind of talk about the concept of like, what is a data engineer? What does their life look like? What are they trying to do, to be successful, whether it's, for themselves, for their own projects, but for the companies or the organizations they work for?
This is such a great question. And maybe we can even go back to the origins of the current wave of data, sure. Which kind of coincides with the time that I spent doing research, trying to use machine learning models to recommend data visualizations, data analyses, semantic type predictions. And back in like 2013, 2014, I would say that was a little bit before data science became such a hot term. Do you remember that?
Oh yeah, no, I remember I think there was a Harvard Business article that said, sexiest job in America, data scientist.
Yeah, that's right. Yeah, so sexy, Hadoop, all the rage, right? Companies trying to get a real competitive advantage by investing in data. And I think companies were right to do that in the same way that software kind of turned from a cost center to a real differentiator for certain businesses to even being at the core of a whole new industry. We're starting to see that a little bit with data.
Okay.
Except that companies put the cart in front of the horse a bit, where you'd hire these big legions of data scientists and machine learning engineers, but the data infrastructure wasn't in place. And right, you can't train the sophisticated recommendation model if you don't even have a table of events, right? Customer data events. And that's what data engineers do.
Yeah. Well, and I remember, it was, there was a lot of sort of cart before the horse or chicken and eggs things of, we've got to hire data scientists, which was, really new in a lot of organizations. They were like, hey, we have business analysts and we have Excel. And then it was like, oh, we're collecting all this data. And then we went through the challenge of, well, but the data's fragmented. It's in this organization or this application or whatever. And everybody kind of looked to a Google or an Amazon or whatever. And they were like, well, gosh, they make all these smart decisions. How do we fix that? And I feel like, yeah, there was a lot of sort of like, well, but if you don't have the right smart people, then you're stuck. But if you don't have the right enough data, then you're stuck. If you don't have the right data infrastructure, then you're stuck. And it was always a little bit of finger pointing in the early days of trying to make this, be successful or add value to the business.
There's so much to do, right? Like not only getting a database that you can fit a lot of data into, but also building all of the connectors to the sources that you might be interested in, modeling the data, plumbing that into different systems so the data can be used. There's a lot of work to do. And the emergence of the data engineer and very recently the analytics engineer is kind of part of that need.
Yeah. And, in the way that you sort of identify those even those two terms, data engineer, analytics engineer, like is one responsible for sort of building the infrastructure so that, data can flow and things can be connected, and another one is, running those Python and R models? Or like even within those two things, how do you, kind of think about it? Or where do you see, what do you see in the industry and reality between those two kinds of jobs?
What I see is that data organizations are very entropic, I would say, where like if you go to one company, what a data scientist does at that company could be completely different from what a data scientist does at another company.
Okay.
And same thing is true for a data engineer. Some terms are becoming a little bit more crystallized so that we see data teams. Like one classic composition is data engineers who are responsible from everything between taking data from a transactional database, like an internal system or an external system, putting it into your data warehouse, to modeling the data, and then data analysts and data scientists using the data. And analytics engineers are kind of in between, where they have the domain knowledge and the business context of a data analyst, but are also able to model the data in the data warehouse. And the emergence of this role makes it such that you're no longer bottlenecked at this juncture where, right, the data engineer stops and the data analyst starts. But this is a very recent development.
Yeah. If somebody came to you and said like, hey, or you were speaking to a bunch of data engineers, like what's their big, I know you said that like different jobs might be a little bit different, but like what are the top 4 or 5, 6 kind of common problems you see them kind of complaining about or wishing went away? Like what's the more modern life of them, right? There's obviously certain things have gotten better, cloud's available, resources are available, but like what are still the big rocks they're having to push, if you will?
This may be oversimplistic, but the job is, at the end of the day, taking data from point A to point B and then transforming it to form C, which is usable to the end user.
Yeah.
And the most important job is to do that, to get the data into the places that it needs to be and then to make it usable. And this already is a huge task for the first data hire at a company. It's been getting easier a little bit with Moore's law basically birthing new product categories into existence, whether it's the modern analytic data warehouse, like a columnar data store such as Snowflake or Redshift or BigQuery, where you have storage that is very, very cheap and compute that scales infinitely, to ELT tools like Fivetran and Airbyte that you can use off of the shelf, instead of having to write custom connectors to do ETL. So a lot of the tools have gotten better, but that makes it so that you have a whole new family of problems emerging, because to have data be used within an organization, number one, you need data. But number two, you need context. Like the people using the data need to understand what it means. And at the end of the day, data just describes things that happen in the real world.
Right.
And number three, you need trust. That when your CFO looks at this financial reporting dashboard, they actually believe that that is the number and not whatever is in their head. So you need data, context, and trust, so that increasingly data engineers are spending their time working on the second two, which are actually very challenging problems, because not only do you need better tech, but you also need to be talking with stakeholders. A lot of human-to-human work.
Right. No, I can only imagine. I know just in my day-to-day job, I may go, hey, I wish I could pull, this query and this query from Salesforce and this query from telemetry about, customer feedback, customer usage of the product, and this trend with, how our SEO program is running. And so, just being able to sort of pull all those things, knowing where to go find it, knowing, am I getting like up-to-date data? How old is it? All those things, just from a, kind of a noob like myself in the data world. I can only imagine it gets way more complicated in pretty sophisticated industries. Go ahead.
By the end of the day, you are the expert. That's the thing that I feel like a lot of data teams are only starting to really realize, is like Brian, the person who's asking for these reports, when you get the data, you know what it means.
Yeah. Yeah, that's true. I do have that context of what we're going to do with it for the business. That's true.
And at the end of the day, right, data is only meant to empower the rest of the organization. I don't mean that in like a buzzwordy sort of way, but I really mean it that you can put all of the data into Snowflake that you want. If no one uses it, there's no purpose in doing that.
Right. Yeah. It becomes a data closet or a data attic or something like that. Yeah, absolutely.
Exactly.
Let's talk about this concept of data observability. We've talked on this show about what we kind of I shouldn't say what the industry kind of called observability, right? So whether it's from a Datadog or Honeycomb or Observe or other companies that label what they do, typically kind of infrastructure or APM monitoring. What does data observability mean to you? What are some of the things that it's bringing to that technology stack?
Well, if we go back to observability, like software observability, I would define it as a concept that describes how much visibility you have into a system. Mm-hmm. And this really goes back to even the origins of the term in control theory, where in control theory, you want to understand, okay, given some system, how controllable is it, right? Given my inputs, how can I change the internal state? Well, if you flip that around, the observability of a system is given the outputs of a system, how can I infer the internal state? Okay. And the three pillars of software observability of metrics, traces, and logs is kind of an attempt to take that idea of like what categories of information do we need to fully infer the state of a software system. And if you have metrics, traces, and logs, right, like whether it's a CPU utilization of an EC2 server, time correlated events that happen across the server and different pieces of your infrastructure, as well as the most granular logs, that you can use these three pillars to kind of reconstruct the state of what was going on.
Yeah.
That's really the goal of Datadog and Honeycomb and Observe is you want to know the state of your infrastructure, not only right now, but also going back. But of course, you can't store everything. Right. So you only need to store the most important parts.
Right.
Data observability applies that same chain of reasoning, but to data systems, right? Like tables in a database, where instead of metrics, traces, and logs, what we like to think about is two pillars that describe the internal and the external characteristics of data, like metrics, such as what is the mean or the nullness of a column in a table, what is the metadata, like the schema and the number of rows and when it was loaded, as well as two pillars describing interactions, whether it's internal interactions like the lineage from one piece of data from another, or logs that describe how it's consumed by external systems, like a stakeholder reading a dashboard, which uses a table in your data warehouse. And this is important because data is fundamentally different from software. Of course, there's a lot of overlaps, right? A lot of data is generated by software systems and stored within software systems. But when it comes to the day-to-day practice, there are some important distinctions. Like, the old adage, like treat your infrastructure like cattle.
Yeah.
You can't do that with data, right? Like data, you have to treat them almost like thoroughbred racehorses. You can't just like drop, 1,000 rows of customer data just gone. I'll just, resume it tomorrow if it goes down.
I'll just spin up another one with whatever data I feel like. Yeah, no, I everybody I know that works in the storage industry sort of laughs sometimes at the guys who work in compute because they go, look, a bad day in compute you can spin back up. A bad day in storage or data is a nightmare. I mean, it's just so yeah, I can completely appreciate that.
For sure. And that also speaks to a bit of how severe data issues can get, right? Like we've been talking about the CFO looking at a fictional dashboard, but you can imagine if this data is going into like a recommender model or like a machine learning model that allocates ad spend, you can quickly burn through like ungodly amounts of money if no one is keeping a pulse on that.
Yeah. So I want to kind of maybe dumb this down a little bit, or kind of maybe put it into business speak. So one of the things, if I talk about kind of application observability or infrastructure observability, like one of the the common kind of use cases is they'll go, well, let's suppose you want to monitor the response time of your website, because you want to know if you're sending out an image of a dress, or you're trying to figure out, like, is there a bottleneck as to why they're not getting to the to the cart and the checkout. What's a kind of common way that you explain to a CFO or to somebody, what is data observability telling me? Maybe that's similar to an analogy like that. Does that make sense?
It does. It does. Data observability tells you when the data may be incorrect.
Okay.
Whether it's from the perspective of a specific task, for example, that we're using data to determine on a daily basis which customers should receive which email. And then if the data that goes into that workflow is is delayed, that's the kind of issue that we would surface.
Okay. Gotcha.
Or like separate from a task, if there's some internal quality issue, like a referential integrity constraint is being violated, which may not cause an issue right now, but could easily cause a fan out and impact many downstream models.
Gotcha. And that makes a ton of sense when you start thinking about how sort of interconnected systems are these days. And this system depends on data from somebody else, and they're going to use it to build their model. And yeah, I can see where that sort of spread could happen very quickly.
Right. And you remember how developing software was, like 10 years ago. And this wasn't true all over the case, but I would sometimes paint it as like you're building a Ruby on Rails app, you push it to an EC2 box, you have a heartbeat check, and you kind of call it a day. Right. There's, of course, this wasn't the case all over the world, but oftentimes the instrumentation that we had was much poorer than what we have today with some of the observability tools that we mentioned before. But in the data world, it's very, very difficult to know when something goes wrong. We like to say that data is silent.
Sure.
Where if a table is usually loaded with 1 million rows every hour, and then 1 hour there's an upstream ETL issue that causes data to not be loaded, typically you won't find out for a very long time. And the first person who finds out is the person who uses that data, right? It's the Brians of the world who are looking at the dashboards and saying, wait a second, this doesn't look right.
Yeah. No, I can definitely see that. And that's one of those, like you said, it's one of those weird frustration moments where you're like, okay, am I losing my mind? Is the data wrong? And you're not really sure what it is. It's a little bit of a murder mystery at that point.
Exactly.
Yeah. I'm curious. So, we've, on like the infrastructure and sort of application side, we've kind of come up with these intersections that happen right between, we call it DevOps, or we call it DevSecOps, or these sort of things where it's like this group needs to work with this group because you're trying to move things more quickly. You're trying to create agility. Do we see those sort of synergies? Is it between the data engineering team and the analytics engineering team? Do we see these sort of like groups that have to work over the fence happen around data engineering and data observability?
Absolutely. And you hit the nail on the head where there's a new term emerging called Data Ops, which envelops a little bit of what you're describing and speaks to the need for almost like contracts between the data team and other teams. At the end of the day, the data team does not produce and does not consume data. Despite us, being called the data or the analytics team, right? Data comes from upstream product analytics, from go-to-market teams in Salesforce and Marketo and your customer support or success tool. And then it goes back into those tools and goes into BI tools. And between the data team and every single team that generates data and every single team that consumes data, I believe there should be a contract in place to set expectations of what data needs to look like and how quickly it needs to be there.
Yeah.
And it goes both ways. Like a very, very common data quality issue that, I've certainly caused this issue is something innocuous, like changing the name of a product analytics event. That can wreak complete havoc on downstream systems, but the person making the change doesn't necessarily know that.
Yeah. So what you're talking about is maybe less of what people would think of as sort of an SLA, where you're expecting, hey, how fast will something happen or how available will it be? You're really talking about something it's a contract in the sense of, there's a recognition or a collaboration between two groups about some common goal. But you're also, it seems like there's somewhat of an education aspect in this, to such that you don't, people realize like, hey, if you make these kinds of changes, which maybe you will or maybe you won't, these are sort of the outputs, or these are the impacts. And if you make these kinds of changes, or you're wanting, twice as much data, you need to understand certain things. I mean, is that
exactly
kind of what you're thinking about? Okay. Yeah. It's like when you're dealing with a builder of a new house, you're like, hey, could you do that? And they're like, sure, but it's going to cost you, or it's going to take this much time. And people don't always understand the ramifications of those changes.
That's totally right. I think, and even if the price tag hurts at first, or if hearing no stings a little bit, at the end of the day, having aligned expectations is good for everybody in the organization.
Yeah.
Because to go back to the idea of trust in data, what we've seen working with like hundreds of teams is that trust is, at the end of the day, your confidence that another party will uphold a contract, right? And it might be a formal contract, but if you don't have a formal contract, you kind of fall back to your informal expectations. And unfortunately, the expectations that the rest of the organization might have on the data team could be almost impossible to fulfill.
Right. Well, and I have to suspect there's also some basic things that if you don't live in the data world, you don't maybe understand the scope or the magnitude of certain things. I mean, so if you told somebody, hey, you get some product manager or some marketing person who goes like, hey, I want all of this viewpoint for the last 30 or 40 days. And you go, okay, well, that's going to take, 75 terabytes. And they're like, well, I don't know what that means. Like, whatever. Yeah, just go do that. Or, having a conversation with somebody and going like, well, how many A/B tests do you run when you're doing this marketing campaign for SEO? Like, should we be running 10,000 or 5 or 900 million, or like numbers sometimes I think when they get big are very hard for people to wrap their head around. They always, they go back to being like, well, how much money do I make, or how big is the hard drive on my laptop, or something that's tangible to them. And so I imagine some of these conversations get kind of a lot of blank stares sometimes. And that's part of the education process, I think.
It definitely is. And also a sign of the maturity of the field, where
sure,
I think like the same thing applied to software teams, like how many across the world, how many, CEOs are like, why can't we just make an API that's always up?
Right.
Right. Like we know how challenging that is. Like every 9 that you add is an order of magnitude more effort.
Right.
But it's hard to understand that from the outside, like you're saying. And I think that's very, empathetic to like see how that applies to the data org too, where, two requests that sound equally complex, like, oh, can you please pull this number for one customer? Oh, and can we please add that other dimension of data to our data set? One could take 5 minutes. The other one could take 5 weeks. Yeah. But it's hard to tell from the outside.
Right. Exactly. I want to wrap up. I want to give you kind of give you a shot to sort of, plug a little bit of what you're doing at Metaplane. Like, what are, for your customers, what are some of the sort of immediate results, whether it's some of the data engineering team sees, or the CFO sees, or the, VP of marketing sees? Like, what are some of the kind of tangible results that folks might expect to see implementing, data observability?
once they implement Metaplane, and we really pride ourselves on being the tool that's the easiest to bring on, right? It's our perspective that data observability should be something that every data team or every company with data should have, not just those that are, prepared to invest a lot of time and a lot of money. And the companies that bring us on almost immediately see a greater sense of data awareness. Whether it's saying, oh, shoot, so this is how my schema is changing over time, and the distribution of tables by row in my database and how these distributions are changing. And then, as issues come up, they face fewer issues of lower severity. They have faster time to identify issues because we have anomaly detection in the background running for you that try and surface outliers, and also faster time to resolve issues because we provide the lineage and the context around issues to help you kind of prioritize and also help you debug. And what that rolls up to at the end of the day is saving engineers time, because data engineers are already, they're already stretched very thin. Sure. But the highest, the biggest bang for your buck is talking with stakeholders and really getting data into their systems and helping them get educated and building use cases around data, not necessarily having to debug, some esoteric outage upstream. So we try and take care of that sort of thing for you as much as we can.
Good stuff. Good stuff. Kevin, like I mentioned, we always love two things. We love digging in with newer companies, people that are kind of, changing the paradigm, what's going on, and also, most importantly, trying to learn about some new topics. So thank you so much for the time today. We've scratched the surface on digging into data observability, lots more on the Metaplane site and things out there. Folks, I want to thank Kevin on behalf of Aaron. I want to thank Kevin for his time. We're going to wrap it up with that. As always, thanks for being on the show. Thanks for listening to the show. Thanks for telling a friend. Thanks to Kevin for listening for 10 plus years. All of you should be like Kevin, right? Just stick with the show. It grows on you. But yeah, we want to thank everybody. Thanks for giving us feedback on the show. Thanks for, giving us ratings in all the places that you listen to the podcast. And with that, I'm going to wrap it up, and we'll talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.